Hello everyone, it's Azim here. Today we're looking at a microscope grid, a grid under the microscope, and this grid, each square of the grid is 1 millimeter in length. We're using this grid so that we can determine the field of view diameter at different total magnifications. So we're going to start out, of course, at the scanning objective, which is 4x times 10x, so that's a total magnification of 40x. I'm going to bring it into focus using the coarse focus knob. And there it is. Now fine focus, just to fine tune it. And here we see our grid. Our field of view is the full circle. And I also have to have a quick disclaimer here. Because I'm using a phone camera, and it magnifies it a little bit more. So if I look through with my own eye without the camera, what I would see is there are 5 lines across. I know on this phone camera it's a little less than 5. But count how many squares there are across. There's 1, 2, 3, 4, roughly 5 squares. Like I said, each square is 1 millimeter long, or 1 millimeter by 1 millimeter, so the radius, the diameter of this field of view is 5 millimeters. We want to use micrometers, micrometers, with a Greek letter mu and the letter m as an abbreviation, as a unit for measuring cells and things that we see under the microscope, because that's the general size of cells. Are really, really small, so we don't want to use millimeters, otherwise you'd be using decimals all the time. So it's better to use micrometers. So 5 millimeters in micrometers would be 5,000. There's 1,000 micrometers in 1 millimeter. 5 millimeters times 1,000 is 5,000. That's at a total magnification of 40x. If we switch to the 10x objective, the low power, so that's a total of 100x. At a total magnification of 100x, again, the camera zooms it in a little bit more than it should be. There are 2 squares. We're fitting across 2 squares in this field of view. And because we have a field of view of 2 squares, that means it's 2 millimeters, in other words, 2,000 micrometers. At a total magnification of 100x, we have a field of view diameter of 100 micrometers. We switch to 40x objective, high power, total magnification of 400. I know it's a bit hard to see because we're so zoomed in, but we are in focus. See, we're at an intersection of grid right there. So I'm going to move it over to the side. We are at less than a square. And that's actually half of a micrometer. So half of a millimeter. Half of a millimeter is 500 micrometers. So at a total magnification of 400x, our field of view diameter is 500 micrometers, excuse me. Back to 10x objective. Back to 4x objective, 40x total magnification. All right, that's how you figure out the field of view diameter at different magnifications. And that will help you in estimating your cell size.